In this video, we are going to practice using the 4 angle theorems that we talked about in our previous video. So it says here, determine the measure of the marked angles in each of the following diagrams. So when I look at the first picture, what you want to do is take a look at the 4 angle theorems that we talked about and see which one most looks like the diagram that we have. So our SATT is for just a basic triangle. I do have a triangle here, but this is for the interior angles, and I don't really know the interior angles of that triangle. Our second one, ETT, is for equilateral triangles, and I should have tick marks on the sides showing that they're all the same, and I do not have that here. ITT is our isosceles triangle theorem. Same thing, it has tick marks showing that 2 of those sides are equal. I do not have that here. And then our last one is our SEAT, or the sum of the exterior angles theorem, where we have our angles on the outside of the triangle, and that is what I am seeing in this picture. So I see that X, 85, and 130 are all on the outside of the triangle. Now Y is on the inside of the triangle, so we will need to do something different with that one, but I'm going to start with those 3 angles on the outside. Now the rule is that those 3 angles should add to 360 degrees. So taking a look here, we're going to start with angle X. I'm going to use SEAT, the sum of the exterior angles theorem, and it says that these 3 outside angles add to 360. So X plus 85 plus 130 equals 360. From here, we're going to collect up our like terms. So 85 and 130 equals 215 degrees. And then in order to solve for X, we want to undo that add 215 by subtracting 215 on the other side. And 360 degrees, take away 215 degrees, is 145 degrees. So I'm going to put that the answer is 145 degrees. I also recommend marking this angle in my diagram because we might be able to use it to help us find angle Y. Now, in order to find angle Y, it is on the inside of the triangle, but I don't currently know the other angles inside. So this is where I would try to use one of the other theorems that we learned on our previous day lesson. Okay. So if I cover up part of the picture, I notice that together X and Y make a straight line. And one of the rules that we learned is that when you have a straight line that has been broken up into 2 or more angles that are back to back, those are going to add to 180 degrees. And that is the rule SAT, or the supplementary angle theorem. So SAT says that X plus Y makes 180 degrees. So I'm going to write that we're using SAT, or the supplementary angle theorem, and that X and Y added together are 145 degrees. So I'm going to put the one we don't know first. So Y plus 145 equals 180 degrees. Right, from there I am going to subtract 145 from the other side. So 180 take away 145 is 35 degrees. So y is 35 degrees. Okay, let's take a look at our next one. So I'm looking at the next question, and I see that we have two triangles that touch at a single point. Now I'm going to try to look at this one triangle at a time to try to help me see things a little bit better. I'm going to start with that triangle. If I take a look through the theorems that we have for triangles, we have the one that the interior angles add to 180. I currently only have one angle and I don't know the other two, so I'm not so sure about using that one. I see our ETT, or equilateral triangle theorem, is when you have three sides that are all the same length. I have three sides that are all the same length. So this angle here should be the same as all the other angles in the triangle, and more specifically, it should equal 60 degrees. So angle X should be 60 degrees because of the equilateral triangle theorem, or ETT. So I'm going to start by filling that in, that our angle X is ETT. I don't need to do a calculation, it's just 60 degrees. Okay, from here, I'm going to look at the other triangle. So if I look at this triangle on this side, if I look through my rules, we've got our interior angles adding to 180. So I do see that I know one of those and we're missing two others, so that's a possibility. This is not equilateral. It does not have any tick marks to show that the sides are all equal. It is also not isosceles because it does not have any tick marks to show that they're all equal. And it is not our exterior angles because I don't have the sides extended and none of those angles are on the outside. So the one that seemed most likely was this one, that my angles add to 180 degrees. But I can't solve if I have two angles that I don't know. So I'm wondering if it's possible for us to figure out one of those. Now, Z is out here by itself, but Y is connected more or less to X. So if I cover up part of that picture, I do see that we have two perfectly straight crossing lines that make an X. And that is my personal favorite theorem, the opposite angle theorem. And it says that the two angles on the opposite sides of those two straight crossing lines are going to be equal. So if this side is 60, this side over here should also be 60. So angle Y is going to be 60 degrees because of OAT, our opposite angle theorem. Okay, once I know that that angle there is 60, I can now go ahead and use the sum of the angles in a triangle theorem and say that these three angles added together are all going to make 180 degrees. So we're using SATT, Z plus 82 plus 60, all three of those together should add to 180 degrees. I'm going to collect up my like terms. So 82 plus 60 is 142 degrees. And then I'm going to solve by subtracting 142 degrees from that other side. So 180, take away 142 is 38. So Z is 38 degrees. Okay, we have one more question in this section, and that is this one. So I'm looking at this triangle, and I'm going to look at my triangle theorems and see which one it most looks like. So our first one, SATT, I do see that I have angles inside of a triangle, so it is possible that I might be able to use that one. When I look at ETT, I don't have all three sides marked as equal. I only have two sides marked as equal. And then ITT, I do have two equal sides, and this has two equal sides. With the SEAT, I do notice I don't have any exterior angles marked here, so I don't think this one is helpful for us. So I am going to try to use the isosceles triangle theorem. I do notice that the orientation is different, so I can either turn the question or I can turn my rule sheet to try to make them look like they're the same direction. So where the two equal sides meet that third side, that's where those two equal angles are going to be. So where the two equal sides meet that third side, this is where those two equal angles are going to be. So that means if this angle is X, this angle here also X. Now, marking this angle as X, that is ITT. That's all ITT is, or the isosceles triangle theorem. It just says those two angles are equal. If I actually want to solve for X, I'm going to need to use another angle theorem, which is my SATT, right, that says that those three angles inside add to 180 degrees. So this is actually a combination of two different theorems together, right? ITT said that those two angles were the same, and now SATT says that if I add those three angles together, so X plus 68, it should equal 180 degrees. From here, I am going to collect my like terms. So X plus X make 2X, and then plus 68 equals 180 degrees. I'm going to cancel out the plus 68 by subtracting 68 from the other side. So 180 take away 68 is 112 degrees. So 2x equals 112. And then I will cancel out that multiply by 2 by dividing by 2. 112 divided by 2 is 56. So x equals 56. So my answer is 56 degrees. All right, that's going to do it for this video. I'll see you in the next one to take a look at our next question.